I'm Nick Federici. Welcome to another episode of Nick is a better teacher than Jake Plaskett. Welcome back to Unit 6. So fun. We are on 6.4, Solving Linear Equalities. So what this basically means is we're back to graphing, and we have to graph linear equality, which is basically, let's say, here's the first example. So we have y is greater than or less than 1. So to solve this on a graph, we go shoop-de-whoop. There's our graph. Y is greater than or less than 1, so we get 1, the number line. This is our line, right? And just for future reference, if it's greater than or less than, it's a solid line, and if it's just less than, or greater than or less than, it's a dotted line. But if it's greater than or less than or equal to, with the little line under, solid line. Okay? So this one's greater than or equal to, so we got our solid line. And because y it's greater than, we shade up. So all this shaded, and that is our answer. So let's do some more. Let's say we have 6y minus 4x is greater than 0. Okay, so we have to make this into y equals mx plus b, so it's add 4x on this side, add 4x on this side, which would give us 6y is greater than 4x plus 0 divided by 6, because y has to be by itself. Divide this whole side by 6. That's what will give us, let's see, y is greater than 4 over 6 plus 0. So 0. So now, and by the way, 4 over 6 is the same as what? If we reduce 2 over 3, which makes things a little easier. So now we're going to graph. Okay, you guys remember those because I'm going to erase them. Here is our graph. We have our intersect is 0, boom, up 2 over 3, so up to 1, 2, 3, over 3. And remember, since it's greater than, and it's not greater than equal to, it's greater than, we do dotted lines. So boom, like that. And because it's greater than, we shade up. If for less than, we shade down. In this case, it's greater than. And that is our answer. And let's see, I think that is about it for solving linear equalities. Thanks again for watching. Have a nice day. Hi, I'm Nick Federici, and welcome to the final episode of Nick is a better teacher than Jake Plaskett. Solid. Okay, we're back to Unit 6. Final episode. Let's do this, folks. 6.6. Oh, real quick. So last time, my apologies, I wrote 6.4. I meant to say 6.5. No biggie. Who cares? But this one, 6.6, Systems of Linear Inequalities. Yeah. Let's get to it. So what this means is it's almost like the last one, except there's 2 equations this time, and you have to like shade accordingly. So our first example is x is greater than or less than 2, and let's say y is less than 4. So, got a little right here. Here's our graph. We're going to go x is greater than or less than 2, so we go 2 on the x axis. Then we go straight up. Solid line because it's greater than or equal to. And then For X's, I know it's a little harder to shade because what is up and down, it's greater than. So the way I remember it is with a greater than or less than sign, whichever one is pointing to, when it's just X is and a number, whichever one it's pointing to, that's the way you shade it. So it's pointing to the right, so we're going to shade the right. But we're not going to shade yet. But we're going to make a note of it that we would normally shade this way. Now, Y is less than 4. Let's do that. So 1, 2, 3, 4 on the Y. There's our point implied. It's just less than, so we dot the line, boom, 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 and it's less than Y, so that means you shade down. So let's just make a note of that. And now, by systems of linear inequalities, what we're going to do is shade kind of like where they both meet. Like where we only shade the part where they're both would be shaded. I know that doesn't make much sense, but I'm going to show you. So you see how for this one, for this line, we would shade down, and for this one, we'd shade that way. So let's compromise. This one, because it's down, we're going to shade right there because it's still down and it's still that way, but it's, you see how it's kind of like in between? How do I explain this? We shade down, but we shade, like they're both shading. You know what? I think you get it. Thank you. Okay. Yeah. See it. Don't need to explain that to you. Just watch the video over and over again. Okay. Awesome. Let's do another one. Okay. So, let's say Y is less than or greater than X, and Y is greater than or equal to, oh, I said less than or equal to 2 as well. X plus 1. Cool. Okay, so now we got, here's our graph. And remember, this is the same as 1 over 1 plus 0. And this is 1 over 1, 2. Okay, so let's graph this one first. Here's our y-intercept. Up 1, over 1. Solid line. Solid. And we're going to shade down because it's less than. But we're not going to shade right. Remember, we're just going to make a note of it. So we would shade down. Okay, here, plus 1, it's our y-intercept. Up 1, over 1. So, up 1, over 1. Down 1, over 1. Aha! Well, look at this. And then we would shade upward, right? Because it's greater than. But because the shadings don't meet anywhere, like they're not joined anywhere, like you would shade this way and this way, that is no solution because the shadings never meet. I would like to thank you for taking the time to watch my videos. It means the world to me. That is the end of my show. Goodbye.